Hi everyone, welcome back to my second video on completing the square. So basically the procedure doesn't change from what we're doing here, but the way we kind of approach it does. So this is the way, the visual way to handle it. The first thing you have to do is still move the x or the 7 to the other side. So minus 6x equals 7. And so what you want to think of now is that this side of the equation, you have a box or a square, actually a square, that has area 7. And so on this side, you're going to have some smaller boxes. So the first thing you want is you're going to have a box that's going to has area x squared in it. And that area is going to have sides x and x to it. Now, you want to take this term just like before and cut it in half. So negative 6x is just negative 3x and negative 3 or minus 3x. So what you're going to have are two boxes that are, one is going to be size negative 3x, the other box is going to be size negative 3x, and notice that this box here will be your negative 3x, so there'll be negative 3 there, and this box here is going to be negative 3x, and that will give you a minus 3. So notice that this already tells you what your what your factorization is going to be. This is going to be x minus 3 squared, because what we're going to do is literally complete the square. So the question is, what goes in here? Well, this side is negative 3 and this side is negative 3, so this is going to be 9. But since you're adding in by filling in the square here, you're going to have to add that area 9 to that side here, and that gives you the 16. And then everything else is the same. You take the square root of both sides, you get x minus 3 equals plus or minus 4, x equals 3 plus or minus 4, so x equals 7, or x equals negative 1 as before. So this gives you kind of a nice diagram way to figure it out. And this is actually where completing the square gets its name for historically. This goes back, over 1,000 years back to the Middle East, where a lot of research in algebra was being done at the time. So this is kind of something that people don't really use anymore that I think is actually a very good tool. But let's do the other example as well to see how we have to slightly modify it for an example like this. So again, we're going to have the 6x squared plus 24x minus 30 equal to 0. And again, we're going to move the 30 to the other side. So again, we're going to also factor out the 6. So we're going to have the 6x squared plus 24x, or sorry, not 24x, 4x equal to 30. So what we're going to do is we're going to have 6 times the area of a square, where one box is made up of x squared, so that'll give you x and x. This 4x is just really 2x plus 2x, and notice I'm splitting it up again, so we'll have one box that is 2x and one box that is 2x here, so this is a 2 here as well, and this should all equal something that has area 30. So now what we're going to do is, like we did before, we're going to add in the area that is needed to complete the square. Well, that's going to be 4, but notice that since we have the 6 times here, we have to add 6 times 4 to the other side. So we'll have 6 times the area of a square that has 4 as an area. And again, this is going to give me 6. The area of the square is given by x plus 2 all squared. And this is going to equal to the area on the right hand side, which is 30 plus 24, which gives me 54. And everything else is the same as before. X plus 2 squared equals 9. X plus 2 equals plus or minus 3, so x equals negative 2 plus or minus 3, so x is 1 or x is negative 5. Everything is same as before. Again, we just get this visual element here. So if you like this method, let me know, because I want to hear feedback about that. This is the first time I've taught this to people. So what did you understand? What you didn't understand? And we're going to move on to the next video. Thank you.